given that show that PQ5 e to power 2 alpha I plus e power negative 2 alpha I is a real number for all alpha. Okay, so this one actually what we can do is we want to show real number. Just remember we want to show that the real part, okay, show that this is a real number. Then we want to show that the imaginary part is 0 ma. So imaginary part is 0. How do we show that the imaginary part is 0? So there are a lot of ways. I mean, you can be thinking about a lot of ways in your head. It could be the Argand diagram. It could be the trying to change it into rectangular or polar coordinates, and you try to show that the imaginary part is 0. Okay, so this actually tests your skills of being able to convert the question into another form such that you can recognize the imaginary part easily or the real part easily, and you straight away can see it's the imaginary part is just 0. So our question here is e to the power of 2 alpha I. Okay, very quickly we can see that this is the exponential form. Okay, the other part is e to the power of negative 2 alpha I, or I can say that this is e to the power of 2 alpha I plus e I negative 2 alpha. So you can see that for this particular right hand side, right, the argument of so maybe this z2, let's say I call it z2, right, is equals to negative 2 alpha. Alright, and here you can see that the mod of z is just equals to z2 is just equals to 1. Okay, and over here what we're going to do is we're going to quickly convert it into the polar form. Okay, just purely the polar form, and then cos 2 alpha plus I sine 2 alpha. This is from here, the blue color portion. Okay, and the red color portion is just cosine negative 2 alpha plus I sine negative 2 alpha. Okay, and using our knowledge from trigonometry, remember we know that if in general cosine theta is the same as the cosine of negative theta, because cos theta is an even function, the sine of negative theta is the same as the negative of sine theta. So I hope you still remember this. Alright, otherwise shame on you. Okay, so after that, this it means that cos 2 alpha plus I sine 2 alpha will keep, and the right hand side here, this is the same as cosine 2 alpha. This is the same as negative I sine 2 alpha. Okay, and similar, and with that, these two will cancel off. You are left with 2 cos 2 alpha, and you can see that this is purely real. There is no imaginary part to this complex number, and we are done. We have showed that this is purely real, so therefore shown. Okay, and next, the complex number w is given by 2 over 1 plus e to the power of 4 alpha I, where alpha is between 0 and pi. We want to show that the real part of w is 1. Okay, so it's really not easy. So what we're going to do is that, again, we are going to try to think about, can I change this to rectangular coordinates? What can I do? Okay, or how does the first part link to this? Right, so even though they did not state any hands or whatsoever, you can also think about trying to get the first part to link to this. So you look at this, and the first part you have showed that e to the power 2 alpha I plus e negative 2 alpha I, you have showed that this is real. Okay, so here, right, we're going to pull a trick here where it actually, right, I can make part 1 appear here. How do I do that? What I do is I actually need to take out or try to factorize my denominator into this form. I pull out e to the power of 2 alpha I. Okay, and within 1 is the same as e to the power of 2 alpha I multiplied by e to the negative 2 alpha I. Here, if I pull out e to the power of 2 alpha I, I'm left with e to the power of 2 alpha I. Okay, so this is how I convert the denominator, okay, by using part 1. Okay, it's not easy to recognize, I must admit. And from here, we know that this portion based on part 1 is nothing but 2 cos 2 theta, 2 cos 2 alpha, sorry. It's just 2 cos 2 alpha multiplied to e to the power of 2 alpha I. Okay, and from here if I cancel off, I'm left with this one 2 alpha I. So what I can do is I can also bring my e to the power on top. I can write it as e to the power negative 2 alpha I cosine 2 alpha. Okay, and now what I do is I can change this into the rectangular form, okay, or maybe the polar form. Okay, I'll write it as cosine negative 2 alpha, right? Because here the argument is negative 2 alpha plus I sine negative 2 alpha over cos 2 alpha. Okay, and with that, we know that cos negative 2 alpha is the same as cosine 2 alpha. So this is the same as cos 2 alpha over cos 2 alpha plus I sine, again sine negative 2 alpha is the same as negative of sine 2 alpha. So this is the same as negative of I sine 2 alpha over cos 2 alpha. And you can see that this gives me 1, and sine over cosine actually gives me a tangent to alpha. So my final answer comes out to be 1 minus I tangent alpha. Okay, and so here this is notably is a rather challenging question because we are, you really need a lot of observation to be able to find the part 1 and appear in the denominator. Right, and from here how we can see that what's the real part of W. You can see that here the real part of W is just equals to 1, and therefore we have showed that the real part is 1. Okay.